This is the video for section 4.2. This is an introduction to trig functions. We're going to start our chapter here. Some of this could be a bit of a review for you, kind of the beginning part, and then we're going to work into some story problems. So we have our 6 basic trig functions. You will maybe remember from the past we had SOHCAHTOA to help us remember sine, cosine, and tangent. You might not know the reciprocal functions. Cosecant is a reciprocal of sine, secant is a reciprocal of cosine, and cotangent is a reciprocal function for tangent. And when we work out our triangles, we need to make sure we pay attention to where theta is. Every trig function has to also include an angle, or an x, or a theta, or something that goes inside of it and is with it. You'll notice in all 6 of these, it's not just sine, it's not just cosine, it's not just tangent. You have the theta with it. You have to have that as you work through your trig problems. Now, whether it's the opposite side, the adjacent side, or the hypotenuse, depends on the angle that I'm given. Hypotenuse is always the angle opposite the 90-degree angle, or the longest side. So that should be the first angle that you try to identify. Then, the opposite side is a good side to identify because it's the side opposite the angle you're given. So in the top triangle, this would be the opposite side. And in the bottom one, because my angle changed, the bottom leg is my opposite side. Finally, I have my adjacent side. So if I found the other two, obviously the third one is adjacent. And that's just the other side that makes up, that's next to the angle. So our first type of problem we're going to look at is, given a function and a ratio, list the other remaining trig ratios. So I have the sine of 30 degrees, which means I need to know what the cosine of 30 degrees is. I want to know what the tangent of 30 degrees is. Cosecant, secant, and cotangent. And for a lot of these, you're going to want to draw a picture. So if I draw myself a triangle, alright, and pick which angle you want to be your 30, I'm going to use this one. It's up to you. Then I got to identify my sides. That's the first recommendation. So remember, opposite the 90 is my hypotenuse. Opposite the 30 is my opposite side. And then the one that's left is adjacent. So now that I have my sides labeled, I need to figure out, what does that 1/2 mean? Well, if we remember, sine is opposite over hypotenuse. Therefore, the opposite side is 1, and the length of the hypotenuse is 2. So the length of this side is 1, the length of this side is 2. Alright. Now, I gotta figure out what's the length of my adjacent side. Because for cosine, cosine is equal to adjacent over hypotenuse. And I know my hypotenuse is 2, but I don't know my adjacent side. You do know that you have a right triangle, so I must have to use Pythagorean theorem. So, we'll call this side x. 1 squared plus x squared equals 2 squared. So 1 plus x squared equals 4. And I get x squared equals 3, square root both sides, and x equals the square root of 3. And I would leave it as the square root of 3. We're going to want definite answers as we're working through this unit. So, this side equals the square root of 3. So my adjacent side, square root of 3. Now that I have all 3 sides, I need to just go through my ratios. Tangent is opposite over adjacent. so 1 over square root 3. Cosecant is going to be 2 over 1. Make sure you reduce that to just 2. Secant is the reciprocal of cosine. So if I know cosine is square root of 3 over 2, secant is 2 over the square root of 3. And the thing that you're going to run into now, that we're in pre-calc, is you have to learn how to rationalize the denominator. You can't leave a square root in the denominator. All square roots have to come out. So what I do is I multiply by the square root of 3 over the square root of 3. And what happens here is when I multiply across, I get 2 square roots of 3 over square root of 3 times square root of 3 is just 3. So 2 square roots of 3 over 3 is my value. Now, if we go back up to tangent, we need to do the same thing. We just waited till secant so we could see it a little better because we're using a 2 in our numerator instead of a 1. So we're going to multiply by square root of 3 over square root of 3. And we end up with the square root of 3 over 3. Cotangent is going to be the reciprocal of that. So I have 3 over the square root of 3. But when I go to rationalize, I end up with 3 square roots of 3 over 3. And if you remember, from our rational expression days, my 3's are going to cancel, and I just end up with the square root of 3. If you also remember that cotangent is equal to adjacent over hypotenuse, you'll end up with the square root of 3 over 1, which is also the square root of 3. So you can do that question 2 different ways. Let's go on to another example. Here I have the cosine of 45 equals the square root of 2. So, to evaluate for the remaining trig functions, I need to make sure I know I'm looking now for sine of 45 degrees. And if you, on your answers, are not putting the 45 with your sine or your cosine or any of your trig functions, those will be counted wrong. Tangent 45, cosecant, secant, cotan. So, I'm going to draw my triangle, my 90-degree angle. Put my 45 up here this time just to be different. Side opposite the 90 is my hypotenuse. Side opposite the 45 is my opposite side, which means the other one must be adjacent. Right? Remember, cosine is adjacent over hypotenuse, which tells me that square root of 2 is my adjacent side. 2 is my hypotenuse. So now I gotta find the length of my opposite side, which will make our x. So square root of 2 squared plus x squared equals 2 squared. Here I get 2 plus x squared equals 4. Take away. X squared equals 2. So x equals the square root of 2. If you recall in the last section, we talked a lot about making sure when you do your square roots that you use the plus or minus. The reason we're using a plus is because we're talking about a distance, and distance cannot be negative. So this side is the square root of 2. So sine is opposite over hypotenuse. So square root of 2 over 2. And it should make sense that those are the same, because if this angle is 45, then this angle also has to be 45. And if I have the same angle length, I'm going to have the same side length. Cosecant is a reciprocal of sine. So I get 2 over the square root of 2. Now I remember I have to rationalize. I cannot have a square root at the bottom. So I multiply by the square root of 2 over square root of 2, and I get 2 square roots of 2 over 2. Well, secant is also a reciprocal of cosine, which is also going to give us 2 over the square root of 2. So we're going to end up with the same thing when we rationalize. And cotangent is the reciprocal of tangent. Well, the reciprocal of 1 is just 1. Here's an example for you when you're finished. Pause the video now, do the example. When you're done, come back and check your answer. Go ahead and check your answers. Alright. Next type of problem. Evaluate using your calculator. Well, here I have two different issues. First, this value is given in degrees. This value is given in radians. So you must make sure your calculator is in the correct mode. You're going to do this by going to settings on your calculator. And making sure where it says angle, that it is in degrees or radians. Once you do this, you want to tab down and hit OK. Then go back to your current document and check out what's going on. See what happens. Alright. And we will go through this in class more. If you're watching the video in Mr. Vorak's class, or Mr. Luke's and you're not sure how to do this, make sure you ask your teacher. Then you're simply typing these in your calculator. So the cosine of 65 degrees equals 0.422. The tangent of pi over 6 gives us the square root of 3 over 3. Now, if your calculator is in the wrong mode, it would tell you that that was 0.009 when you do it, but that is not correct. It needs to be in radians, so if it's not in radians, it's going to give you a wrong answer. So make sure you double check. If you're not sure, type in the sine of 30 degrees, and if you don't get a half, you know your calculator is in the wrong mode. Next, find the acute angle that satisfies the given equation. So now, I have a ratio. I want to know how big is my angle. What's my theta? In order to undo those, I use the inverse functions. So I do the inverse sine of 4/7 in my calculator, and it's going to tell me theta. Or I do the inverse cosine of 5 over 11, and it's going to give me theta in this case. Now if you do this, you should get 34.85 degrees. For cosine, I get 62.964 degrees. And once again, depending on what you're given, if you want your answer in degrees, you need to make sure your calculator's in degrees. If you want your answer in radians, make sure your calculator's in radians. Now, we're back to some problems that you should be used to with some naked triangles, and I just want to find the variable. So, I need to identify my triangle. Here is the angle I'm given. I know that opposite the 90 is my hypotenuse. Opposite my angle is the opposite side, and then the other side is adjacent. So I got to figure out, what do they give me in this question? Well, they give me the opposite side and the adjacent side. Which one of my trig functions deals with opposite and adjacent? Tangent or cotangent? And I would probably use your three basic ones as much as possible. So we know that the tangent of 32 degrees equals our opposite side x over our adjacent side 13. And now I'm back to solving an equation. Alright, so I want to get x by itself. I'm going to multiply both sides by 13. My 13s are going to cancel over here. And I type in my calculator 13 tan 32. Make sure my calculator is in degrees. And it's going to tell me that x equals 8.123. Make sure, because you're given a degree measure, that your calculator's in degrees when you're doing these problems. Pay attention to what the angle is given to you at. Go ahead and pause the video and try this one on your own. You'll notice as you're working this one that you get something that looks like this. So obviously the variable I'm looking for is my theta. Remember, when we're looking for theta, we do the inverse function of the ratio, and that's going to give us our angle measure. In this case, get 28.81 degrees. Here are two for you to try. Go ahead and pause the video, try these two, and come back and check your answers. Here are the answers to the two examples. Check your work. Moving on, we will see. Now we're talking about solve the right triangle. So you're doing the same types of things, except now you have to find all missing sides and all missing angles. So we don't know the hypotenuse, so we'll call that h. We don't know this angle, so we'll call that little a. And we don't know this side, so we'll call that x. So we want to find a, h, and x. Okay. I would start off, I know that all the angles on a triangle have to add up to 180 degrees. Since I know that this one's 90 and this one's 42, I can find little a by doing 180 minus 90 minus 42, and I get 48 degrees. Then I need to use my other functions to find my values. So I know that this is my hypotenuse, this is my opposite side for 42 degrees, which makes this my adjacent side for 42. And I'm going to start using my trig functions to solve these. Well, I have the opposite, and I'm looking for the hypotenuse. So the sine of 42 degrees equals my opposite side of 4.5 over h, my hypotenuse. And I solve this just like I did the last ones. Multiply both sides by h. And then divide by the sine. And I'm going to find that h equals 6.725. Now I got to find x. X is the adjacent side, so I can use the tangent of 42 degrees equals my opposite side over my x, my adjacent side. Same thing. Multiply both sides by x. Divide. And I get x equals 4.997. Here's an example for you to try. Pause the video, solve the triangle, and come back and check your answers. Here are the answers. When you're finished checking your work, you can now move on to the homework. Homework is page 366, 1 through 18, and 33 to 58 odd out of your textbook.